Hello, and today's learning target is I can multiply monomials in scientific notation. So we are going to multiply the following numbers that are already in scientific notation. Make sure the final answer is also in the proper scientific notation form. So let's take a look at this first example here. I have 6.5 times 10 to the negative third times 7 times 10 to the fifth. So what I'm going to do is I'm going to multiply the coefficients here of 6.5 and 7 to begin with. In my calculator, when I type that in, I get 45.5. Make sure you get the same. Good work, you did. Now, with my exponents with the same base here of 10, if you recall back from our beginning monomials unit, when I multiply exponents with the same base, I really just add their powers. So I have negative 3 plus 5, which is 2. So this is times 10 to the second. However, I am breaking a rule in scientific notation right now. This is not my final answer because this first number has to be between 1 and 10. It can't be 10, but it could be 1. So what I need to do is I need to change this decimal here from 45.5, move it over 1 to the left, so that it's 4.55 because now that's a number that's between 1 and 10. Now when I do that, since I moved it 1 to the left, I originally wanted to go 2 places to the right, 10 to the second power, when it was here after the 45. That decimal was after the 5. Now when I moved it 1 to the left, that requires me to go another spot, or if I move the decimal to the left, it requires me to move another spot to the right. Now I'll have to go 3 spots to the right because that I moved that decimal over. So I'm going to have 2 plus 1 and give me times 10 to the third. To check our answers, we could put this into standard form. 45.5 times 10 to the second means I move my decimal over 2 places, 1, 2, so 4,550. If I have 4.55 times 10 to the third, I move that over 3 place values, 1, 2, 3, fill that with a 0, just like this last one. I get 4,550, which is the same thing, so I did that correctly. So my final answer is 4.55 times 10 to the third. All right, let's look at this next example. 6.5 times 10 to the 12th times 1.95 times 10 to the negative 15th. So 6.5 times 1.95 is 12.675. I know I'll have to change that in a moment because that's not between 1 and 10. Times 10 to the, I'm going to add 12 plus negative 15, and 12 plus negative 15 is negative 3. However, I'm going to move the decimal 1 place to the left. And so I originally wanted to go 3 spots to the left, right, because it's a negative. So now if I already move it to the left once, now I only have to go 2 spots to the left. And again, when we go to the left with that decimal, we add an exponent. So when I do that here, I get 1.2675 times 10 to the negative second, because negative 3 plus 1 is negative 2. And if you think about it, like I said, we want to move 3 places to the left with that negative 3 right there, but if we move it over 1 spot here, from after the 2 to before the 2, that's 1 less spot to move to the left that we'll need to go. So this will be my final answer, 1.2675 times 10 to the negative second. And again, I could rewrite these to standard form to check my work as well. I'm not going to do that right now. We did that on the first example, but feel free if you would like to show a little bit more work, you can certainly do that. Let's take a look at the next example. All right, I have 3.5 times 10 to the negative third times 7 times 10 to the fifth. So in my calculator, I'll type 3.5 times 7. And I get 24.5 times 10 to the negative 3 plus 5 is 2. Again, we add the exponents with the same base. But this is breaking a rule again because my first term has to be between 1 and 10. So I'm going to, and I accidentally wrote 5 there, that should be a 2. I'm going to move my decimal 1 place to the left, so I get 2.45. And then I'll add an exponent there, again, because I moved to the left, times 10 to the third. And again, if it was 24.5 and I wanted to go 2 places to the right, if I move it over 1 to the left, that means I have to go an additional place, with that decimal to the right to get my standard form answer. So that's why it also moves up to 3. So 2.45 times 10 to the third. All right, let's look at the last example here. 4.3 times 10 to the negative third times 4.5 times 10 to the fourth. So 4.3 times 4.5 is 19.35 times 10 to the negative 3 plus 4 is 1, so times 10 to the first. But again, this number needs to be between 1 and 10 without being 10. So I'll move it 1 to the left, which means I need to add an exponent. Whenever I move it to the left, I add an exponent. So I get 1.935 times 10 to the second. And that would be my final answer. Now, on all these examples, we did move our decimal to the left, so we always added an exponent. We're going to see when we divide in our next lesson what happens when I need to move the decimal to the right. So right one spot would have me subtract an exponent. So again, that's moving to the right. Here we move to the left, one decimal spot, so we added an exponent. And that's plus 1. And if we ever had to move the decimal over 2 places to the left, we'd add 2 to the exponent, or 2 places to the right, we'd have to add 2 to or subtract 2 from the exponent. So we'll look at a few more examples and different types when we also look at dividing with scientific notation. Thanks for listening. Have a great day. Bye-bye.